I'm going to demonstrate one of the similar components that we've used for one of our clients, but you can see this pattern commonly in a lot of applications. This will be a component that uses both a vertical scroll view and a horizontal scroll view. So from a UI perspective, it's going to start as this vertical scroll view should scroll over the edge of the screen, over the top edge of the screen. And the horizontal scroll view will be images, so it will be paginated and it will scroll horizontally. So it may look simple at first, but there are a couple of gotchas and tricks that should be done for this to function coherently as a whole. So the motivation for this workshop is the PanResponder API documentation may not be as straightforward for a beginner, and throughout this workshop, we can learn how to translate UI UX requirements into code. So you can level up your skills in the core API of React Native itself, because we won't be using any libraries for this. Now, step 1, create the components individually, the horizontal scroll view and the vertical scroll view. So I've prepared already some Git commits here, some hashes, so we can save some time from actually typing the code, and we can just check out from these hashes. So we started out with the React Native init project, so it's really from scratch, and the first one is to create a horizontal scroll view component. This will be pretty simple. Okay, so this is the component. It is just the scrollable scroll view to display some images. And if we look at the code, yeah, so it just consists of a view, scroll view, paging enabled true so that it snaps to each of the image, horizontal to true, and we map the images to a view component. It has a height of 200 and the width equal to the dimensions of the window, so it encompasses the whole width of the screen for any device. So now we're going to check out to another hash. For this one, we checked out to the vertical scroll view component. So for example, this is the normal structure of the two scroll views. If they have the default position, which is relative, so none of them are absolutely positioned right now, so it doesn't achieve our goal of having the vertical scroll view run over the top edge of the screen. So one of the gotchas here is that if you apply the absolute positioning on the vertical scroll view, it wouldn't function correctly anymore. So we have to apply the absolute positioning to the horizontal scroll view. So in a moment, yeah, and we can see here that it's still working. The horizontal scroll view is still working. But if we apply the absolute positioning on the horizontal scroll view, now we have achieved one of our goals, which is the vertical scroll view is now scrolling over the top edge of the screen, but it doesn't look as good anymore. So the next step will be to create a padding. So we created a component here that has a similar height 200, that has a transparent background, but it serves as a padding for the vertical scroll view. So actually the vertical scroll view here is already encompassing the whole width and the height of the screen, but there's an invisible component here to protect this horizontal scroll view from being blocked by the horizontal scroll view, by the vertical scroll view, I mean. And we just made its background red, so we can see much clearer in the demonstration that it's now working as expected. But one of the problems that this introduces is, since the vertical scroll view is encompassing the whole width and height of the screen, you cannot use the swipe gestures for the horizontal scroll view anymore. Because in a UI perspective, it gives the illusion that you can interact with the horizontal scroll view, but actually, from a functional perspective, since the vertical scroll view is encompassing the whole width of the screen, your touch gestures wouldn't pass through anymore to the horizontal scroll view. So in this moment, I was trying to drag it, but it's not working anymore. So the solution for this one is the PanResponder API. So next checkout is where we'll introduce the core PanResponder API. We're just using a method. So we have a handle swipe method defined in our application component, and it just sets the state. So we have an active index state that takes the length of our images array. And after we set the state, we've defined a ref for the horizontal scroll view to scroll to a specific x axis value that is equal to width times the length of the active index. So if it's the first image, it'll scroll to 0. If it's the second image, it'll scroll to 200, and etc. Okay, so now we have that method. We're going to show next how we can have an overlay, an invisible overlay that will capture the user's swipe gestures so that we can bind this handle swipe function on those swipe gestures and make it behave, show an illusion that it's behaving as expected. All right, so now we're going to check out to the PanResponder method. All right, so so our invisible component a while ago that we've introduced so that we can see the horizontal scroll view clearly without being blocked by the vertical scroll view. We've given it a green overlay background, so it'll be much easier while developing. But basically, we've assigned the PanResponder object that we've initialized using the core PanResponder API and created it with these properties. So on start should set PanResponder. It should return to true. We can set some conditions here to either return true or false for specific gestures, but for our use case, it can simply just return to true always, because any touch in here should be registered as something that the user is trying to do something with the carousel or the horizontal scroll view component. And we've also define this handle PanResponder move method that takes in 2 arguments. This one is a native event and it won't be used. That's why we named the variable as an underscore. And the second variable is the gesture state. And this gesture state contains what we need to detect if the user is really scrolling. So we've named our variables horizontal swipe velocity as gesture state.vx. And the threshold is 0.7. This 0.7 value is completely arbitrary. It's something that I've discovered through trial and error. It's just enough to register the scrolling behavior. And for this demonstration, we're just going to demonstrate the swipe right method, because the swipe left method would simply be the inverse. All right, so moving forward. In this part, I was explaining what each of these variables and values mean. And in a moment, I'll show the debugging. So, for example, if you swipe slowly, it's registering as false. So, because we're swiping so slowly that it's not supposed to mean as a real swipe right. So it has to be on it has to beat the certain momentum threshold to register as a swipe. So that 0.7 is the momentum threshold that we've defined. And now we've bound the swipe right. The PanResponder move is now being bound to the method that we've defined before for our button. So we've also defined here. So this one, I've commented it out for now because this one is actually also a gotcha when doing this kind of trick, because when you do a handle PanResponder move, it doesn't have a natural way to stop registering the devices. So if the user swipes right hard enough, it is going to register multiple swipe rights and it's going to mess up our state. So that's one of the other things that the PanResponder Core API has. It's on start should set PanResponder. No, on PanResponder grant. So when we've granted the PanResponder, the trick here is to create a property of the component that will be equal to the current index of the image. That means we're going to save it to memory somehow so that when we swipe, after it registers the first swipe, alright, so here there's just some more demonstrations for the swiping methodology. Okay, so we've enabled the guard now. So in here we're showing that if the active index on PanResponder grant is not equal to the active index, that means that the horizontal scroll view has moved already. So if this is true, then we're just going to ignore all the other gesture that has been captured. All right, so skipping this part. All right, so it's now working. And for the final gotcha of this component is that since we have that invisible overlay that is absolutely positioned, now our user won't be able to scroll up and down if they scroll over this area. So that is where we're going to use the Core Animated API to somehow bind the scroll offset, the Y scroll offset of our vertical scroll view to reduce the size of this overlay once we've scrolled far enough. Now we're going to check out to the commit where we have that. Okay, so we have the animated API and we initialized a scale animated value property of our app component to 1 because we want the overlay to start with 100% size at first, but we've defined also a scale transform. So basically the value of these scale transforms will be 1 if the vertical scroll view is at the top, and as you scroll down it will slowly shrink down to 0. And there are a couple more gotchas in here that we will be showing in a while. Okay, so in here we are going to show how we've actually bound the scale animated value to our vertical scroll view component. So we passed in it, we defined it in the app component to the root component, but pass it in as a prop to the vertical scroll view component. And we've made the scroll view. Before it was just a normal scroll view, but we've made it to an animated scroll view component that takes in on scroll as a prop. And we can generate the binding using the animated event method. And it takes these values as its arguments. So this Y property means that we're binding it to the Y scrolling of the component since it's vertical. But we can show here that we can simply add another property to the scale transform interpolation, and this is the extrapolate property, and it's called clamp. So what's happening a while ago is start at the top. So this is a 0 offset. So this is scale X and scale Y is 1. But as you scroll down, if it exceeds the 50 Y offset mark, it's going to crawl back to 1. So that can be useful for some scenarios wherein you want to loop the animation, but for our case, we just would like to have its value stay at 0 when it exceeds the 50 pixel Y offset mark. So we've introduced the extrapolate clamp property here, and now it won't behave that way anymore. It will stay at 0 at and after the 50 Y offset mark. So as you can see, even though it's working as expected now, the performance is still not that smooth. And the last gotcha that we have here is to simply introduce the scroll event throttle. So this property takes in a number as its value, and it's basically the milliseconds on how many times the scroll view component would update. Since we're using the native driver to true, it will be smooth and it wouldn't suffer any performance here. So now we have a very smooth component. So basically this is how it behaves. And okay, so in that presentation, we've shown how we can use the 3 core React Native APIs together, ScrollView, Animated, and PanResponder, to create a common UI UX pattern. And we've actually used that in the real world for one of our clients.